Welcome to This Explainer. Look, we all know the AI hype cycle is absolutely deafening right now. Everyone's talking about agents. But if you're a developer or a builder in the trenches, you know there is a massive gap between a cool demo and a robust, scalable system. Today, we're unpacking the critical mechanics of how artificial intelligence is actually evolving right before our eyes. We're moving away from passive conversationalists that just spit out text, and we're stepping squarely into the era of active, task-executing systems. We are going to look at the exact architecture making this possible. Before we get into the technical weeds, let's just strip away all that marketing jargon. We need to answer one fundamental question if you're building or even just using AI today. What actually makes an AI agent, an actual agent?
Well, the harsh truth, without the ability to take real-world actions, your AI is literally just a chatbot. We've all been there, right? You ask a super smart model to help plan a trip or fix a bug, and it gives you this brilliant, perfectly formatted 10-step list, basically saying, hey, good luck doing all this yourself. Sure, it can talk, it can write code, but it can't actually do the thing for you. Getting models to take action is the holy grail right now, and the secret to unlocking that, turning a passive chatbot into a true autonomous agent, comes down to two architectures, APIs and MCPs.
Here's our roadmap for This Explainer. We'll cover chatbots versus true agents, APIs acting as a hard-coded door, MCP as the discovery protocol, the hybrid powerhouse, and finally, a decision framework for your own builds. Let's jump in.
Okay, Section 1, chatbots versus true agents and the absolute need for action.
To really grasp the difference here, let's run a quick conceptual test. Imagine we line up three identical AI brains. They're all running on the exact same underlying model, using the ADK, or Agent Development Kit framework. We give them the exact same task, say checking the hyperlocal weather in Austin or grabbing NVIDIA's real-time stock price. The only variable is how we let them talk to the outside world. Agent 1 uses a traditional API, Agent 2 uses the Model Context Protocol, or MCP, and Agent 3 uses a hybrid of both. Let's see how this plays out.
Moving to Section 2, APIs, the hard-coded door and traditional software connections.
So, to understand the baseline of how software talks today, we have to look at the traditional API. Think of an API like a solid steel door with a totally unforgiving bouncer. One program walks up, knocks, and has to ask a question in a highly specific, rigid format. If your syntax is flawless, the bouncer hands back a very specific answer. But if you miss a single comma, bam, the door slams in your face. Now, APIs are absolutely perfect when a human developer physically sits down, reads the docs, and wires those connections by hand. But for an AI, the agent only knows the one specific trick it was manually programmed to do. It has zero actual autonomy.
You'll see a few common flavors of this out in the wild. You've got REST, which is the everyday standard most of the modern web runs on. Then there's GraphQL, where you ask for exactly the fields you want, no more, no less, to save bandwidth. And Webhooks, where a system proactively calls you based on event triggers instead of you constantly pulling it. Developers often build these using elegant tools like FastAPI in Python, which literally turns a normal Python function into a live endpoint with just a single decorator. Super cool, right? But here is the massive catch. Even the easiest API still requires a human to explicitly wire it to the AI.
And that brings us to the absolute core problem with pure APIs at scale. With the traditional model, human developers are practically drowning in manual wiring. Every single new capability your agent needs means you're writing more code, running more tests, and committing to maintaining that connection forever against breaking changes. But what if we completely flip that paradigm? What if, instead of hard-coding every single pathway, the agent just walks up to a new system and asks, hey, what can you do for me? It completely shifts the heavy lifting from human manual labor directly to the AI's autonomy.
Which leads perfectly into Section 3, MCP, the discovery protocol, and dynamic tool integration.
This right here is where the Model Context Protocol changes the entire game. The breakthrough is runtime discovery. With MCP, the system itself holds a menu of its available tools, things like fetching the current weather, checking a forecast, or analyzing air quality. You just point your agent at the server, and it instantly reads the menu. It discovers and uses tools dynamically based on what it actually needs to get done. Absolutely nobody has to sit down and write the manual glue code to connect the agent to those specific endpoints. It honestly feels like magic the first time you see it work.
Let's walk through how this actually plays out with a complex task, because this is the exact moment an AI becomes a true agent. Say you prompt it to compare today's weather in Austin versus tomorrow. First, the agent connects to the MCP server and asks, "What can you do?" Second, the server lists its available tools. Third, and this is where the magic happens, the large language model independently plans the sequence of actions. It realizes, hey, I need data from 2 different sources to answer this. Finally, the agent executes the current weather tool, followed seamlessly by the forecast tool, and synthesizes the results. When an AI can independently plan and sequence multiple tool calls entirely on its own, that is the agentic behavior we've been chasing for years.
Now, the biggest implication of this architecture, it completely eliminates vendor lock-in, because you build the MCP server once, and any compatible agent can knock on the door and ask for the menu. That's exactly why the entire tech industry recognized its massive potential and, back in December, handed the open standard over to the Linux Foundation. We are talking about unprecedented, unified backing here: Anthropic, OpenAI, Google, Microsoft, and Amazon. You build your tool once and it works flawlessly whether your user is running Claude, ChatGPT, Gemini, or some locally hosted open source model. It is fast becoming the universal standard for agent actions.
All right, Section 4, the hybrid powerhouse, combining discovery with precision.
So, the ultimate solution for developers isn't actually forcing yourself to choose between pure API or pure MCP. Take a nuanced prompt, like asking an agent to recommend a great park in Austin to visit right now. With a hybrid approach, you get to watch the agent's real-time reasoning. First, it dynamically checks the weather MCP to verify it's a sunny, beautiful day, 0 manual wiring needed. But then, it realizes it needs sub-meter routing accuracy to actually get you there. Since an LLM might hallucinate directions if left entirely on its own, it deliberately calls on a dedicated, highly precise Google Maps API to draw the map and reliably route you to Pease District Park.
This is essentially the core best practice for modern AI development right now. Teaming up dedicated, highly precise APIs alongside the dynamic discovery of MCP creates the most efficient, robust agentic workflow out there. You get the pinpoint reliability of an API exactly where you need guaranteed structure, and you combine that with the infinite scalability and autonomy of MCP everywhere else. This balanced architecture is exactly how real, fault-tolerant production agents are being built in the trenches today.
Let's wrap up with Section 5, your decision framework for when to use API, MCP, or hybrid.
When you sit down to plan your next sprint, here is your playbook. Use a pure API for single, highly specific, predictable tasks where precision is absolutely non-negotiable. But just know the human developer effort for maintenance is going to stay pretty high. Turn to pure MCP for broader systems that need scalable, dynamic tool discovery. The developer effort is incredibly low here, since the agent does the heavy lifting at runtime. And finally, lean heavily on the hybrid approach for any complex, real-world production agents. It gives you a perfectly balanced architecture, ensuring your systems scale endlessly without ever sacrificing that mission-critical precision your users demand.
The shift from rigid coding to dynamic discovery is just profound. It fundamentally changes absolutely everything about how we build technology. It finally frees developers from that endless, grueling treadmill of integration maintenance, and it genuinely empowers AI to step out of the chat window and take real action in the physical world. Which leaves us with one final, pretty exciting question to end this explainer on. Now that your AI can dynamically discover its own tools, what impossible software are you going to build tomorrow?